Thank you very much. First of all, I want to apologize a bit because this is not a very scientific talk. It's mostly about presenting this project I've been working on, which hopefully will be a useful tool for the community working on this type of objects. So I don't need to convince this audience about the importance of episodic accretion. You all think it's important, and that's why we're here. But in case you need extra convincing, we all know that this idea that objects spend most of their lifetime in quiescent states and gain most of their mass in these short-lived episodes of high accretion is one of the models that has been brought forward to explain what used to be called the luminosity problem, but now most people talk about this luminosity spread in areas of star formation. There are also several theoretical works, I don't put them all here, that have tried to study the impact of these accretion bursts on both stellar formation and planetary formation. And some of them have found that these episodes of high accretion can have a long-lasting impact on the structure of the central star. As we have seen, and we will see during this conference, we know that these outbursting stars are fantastic laboratories for the study of chemistry and planetary formation. For example, the study of complex organic molecules in the outbursting source V83 Ori, as well as the first potential evidence for planet formation through gravitational instability in the outbursting source V960 Mon. But there are several things that are still uncertain in episodic accretion. So we still don't know whether episodic accretion is universal among YSOs, or if these outbursting stars are a special breed of objects that are following a particular path in their evolution. We also have uncertainties on the frequencies of these events, although there has been improvement over the last few years. However, one of the main caveats on any statistical analysis trying to determine this frequency always assumes that episodic accretion is universal. So that's a big question mark there. We're also not quite sure what's the physical mechanism leading to this outburst, whether there's only one or we have a combination of many mechanisms that lead to this type of outburst. But to answer all these questions, every effort we need additional discoveries, and we have been doing that, and also accurate statistics on the number of YSOs that belong to the eruptive variable class. And as I said, we have been trying to do that, especially thanks to the recent multi-epoch surveys like Gaia, ZTF, BVV, the Galactic Plane Survey, and also the JCMT Transient Survey. As I show here in this plot, we had been systematically finding these outbursting YSOs since the 1950s, but thanks to these multi-epoch surveys, we have been tripled the number of YSOs, of eruptive YSOs that have been confirmed so far. However, the latest available catalog of the number of objects that are confirmed as eruptive YSOs was provided by Mark Goddard in 2014 in Protostars and Planet 6, the chapter on episodic accretion. So I had this idea. It was always a bit annoying because, especially for proposal season, I always had to go back and look at every paper and try to understand if we had new objects or not. So I decided it would be a good idea to maintain a database on this type of objects. In the current version, where I have tried to include many people that are actually present in this conference, I received a lot of positive feedback, and I take the opportunity to say thank you. I am trying to include every comment that I received so far into this paper. The idea is to publish a paper which is basically presenting the number of objects and some very basic information on these objects in the Journal of the Korean Astronomical Society, and also to maintain a website at Seoul National University, where I will try to include new objects as they come along. So in the current version of the paper in the website, I'm trying to maintain the classification that was given by the authors in each discovery paper. So I'm not trying to reclassify things here, but perhaps that will change after this conference, I don't know. But perhaps also will serve as a basis for a future reclassification, perhaps on other characteristics. So basically, right now, I'm using the usual way, which is so photometry, so light curve morphology, and spectroscopy. And so far, then, I have this list has 163 confirmed YSOs, eruptive YSOs, and a list of 245 candidate eruptive YSOs. Okay, so the first, as I said, I tried to put all the objects into the known subclasses of eruptive variability, and I tried to follow whatever the authors have said in the discovery papers. The first class is the bona fide FEORs. We have heard about these objects during the conference, where basically, in terms of photometry, I try to include things that have a single outburst, that is a long-lasting outburst, usually longer than 10 years. And in terms of the spectrum, that they display all or some of these characteristics, which is the change of spectral type from optical to near-infrared wavelengths, not mid-infrared. Of course, this is not possible for every object, especially those ones that have been discovered in near-infrared surveys. Also the observation of H-alpha P Cygni profile in the optical, and also in the near-infrared observing water and 12CO absorption. This sort of spectroscopic criteria comes mainly from the paper by Connolly and Ryport 2018. And so far, I have 45 objects in this class, which include, we have heard about this particular object, Gaia 17 BPI, and include many of the newly discovered objects by the VVV survey. Second class is the FEOR-like survey objects, which have similar spectroscopic characteristics to bona fide FEORs. But in this case, we have not seen or we have not recorded an outburst. So we call them FEOR-like sources. There are only about 13 objects in this class so far. This is one example. This is a well-known object, L1551, where we see this, the P Cygni profile of the H-alpha line. And in the near-infrared, we see the water and CO absorption. Here, things started to become a bit more complicated in terms of what we call a bona fide EX loopy source. The usual classification says that we see these short-term outbursts, usually lasting between 1 to 2 years, and that sometimes can be repetitive. And in the spectrum, we see this change from quiescence, where the spectrum shows an absorption type spectrum, very similar to classical Titori stars. And when they go into outbursts, we start to see some lines going into emission, like sodium and 12CO in the near-infrared. Currently, I have 14 objects in this class, which include this very nice source, Gaia 20 EAE, which is it's very hard not to classify this as a bona fide EX loopy. However, the problem that I found is that EX loopy itself, which has this, it's been covered since the 1890, it shows this burst and outbursts. If we look at the 2008 outburst, we see all the characteristics we would expect from bona fide EX loopy stars. But if we look at the 2022 outburst, I don't think we would call that a bona fide EX loopy star. So there are some questionings there. And then I look at objects like, this is a classical EX loopy type object, VY tau, where we see a lot of these sort of 2 to 3 magnitude outbursts. In the paper in 1977, George Herbig does claim that there is a change in the spectrum at maximum light. However, it was hard to find more information on that. And I keep these objects because these are sort of the classical ones in the list, but they have a question mark. So it's a bit hard to include these kind of objects. Now we have this, what I'm calling in the paper, the PVM class, because these are generally classified as either peculiar, V1647 Ori-like, or my personal favorite, because I said it, MNORs. So this kind of object is basically, this is the largest class at the end, because we have 85 objects in this class. And basically we have this sort of combination between EX loopy type and FUR type outburst. So the outburst durations tend to be longer than EX loopy type, but shorter than FURs, and the spectra is all over the place as well. Here is a very nice example of the kind of objects I'm putting in this class. This is V322 from the VVV survey, where we have about a 5-year outburst, 4 to 5 years outburst, which we wouldn't call an FUR from photometry, but then when we look at the spectrum, it looks very similar to FUR type outbursts. So these kind of objects go into this class, which I'm calling PVM, trying to use all the classification that has been used for these kind of stars. And finally, this is also, I'm still thinking a bit about this. I'm putting 5 objects into the embedded class because these are class 0, class 1 YSOs, where we cannot do follow-up at optical or near infrared because they're too faint, but where we have seen these huge outbursts when we look only at mid-infrared wavelengths and far-infrared wavelengths as well. This is HOPS 383, which we know is an outbursting source, but we have no way of classifying it as a FUR or an EX loopy type object. But there's right now I only have 5 objects in this class. Finally, I have 245 objects which are candidate eruptive variable YSOs, and this is because in most cases we only have photometry. In some cases, we have spectroscopic follow-up, but the authors in the papers haven't been able to actually confirm or firmly say that these are eruptive YSOs. One very nice example is this one is HOPS 20. This is a very real 5 magnitude, 6 magnitude change in the K-band since the year 2000. However, when we discover it, we realize 18 magnitudes, we're not going to see anything. So we assume this is an outburst, but there's no way to confirm it with spectra. Also, some of the periodic sources from Shen's papers that these are 3 magnitude outbursts, periodic outbursts. We believe it's related to accretion, but there's no spectra in some of these cases. So we have a list of 245 objects that are like this. And as I mentioned, we have some objects in this list which are show high amplitude variability. We have spectra, but in this case, this is from one of my papers. Even though it shows a featureless spectrum, we could say it could be an eruptive YSOs, but because I'm not sure whether I measured this, I observed this spectrum during quiescence or at the bright state, it's hard to say what's going on. So it remains as a candidate. Okay, finally, the information that I'm including right now in the paper and the website is very limited. So basically the name of the objects, location, the classification in terms of a spectral index, distance to the sources, and for the confirmed eruptive YSOs, I show the amplitude in 6 bands, so V, R, G, K, W1, and W2. And I give basically 3 classifications. So if we look at the spectrum, whether it's an absorption-dominated spectrum like an FUR, whether it was observed both at optical and infrared or only in the near infrared, a light curve classification, so FUR means it's a long-term outburst, and finally the final class, which in this case is bona fide FUR. If we have a period in some of them, I put the period and then the references where I try to include the original classification discovery papers for each of the YSOs. And for the candidates, similar information. The only difference is that I only provide 1 amplitude value and sort of the filter that was used to provide that amplitude. And well, based on the feedback I received from many people, I am planning to include additional information that would be useful, like luminosity, current brightness, among others. So if anyone has any idea of what they would like to see in the catalog, please talk to me. I'm more than open to suggestions for this work. So, and in terms of, I know that many people that have been included already, I sent a link to a website that never worked. I am sorry about that, but I have finally fixed that. So after this conference, I will send that link. It's still password protected, so because we haven't published yet. So thanks for listening, and I do hope that this becomes a really useful tool for the community. Thank you.
Questions?
Thanks for the nice talk. May I ask, at least from a user's perspective, what would you say are the key differences between this catalog and the catalog named Nemesis that was presented a while ago, which basically uses machine learning to also classify young stellar objects?
I try to include here things that are definitely confirmed as eruptive variable YSOs. So where we actually have spectroscopic confirmation. And in the candidates, most of these works are, for example, all the objects in the candidates are marked L222, are from Shen's papers. Basically objects that show the high amplitude variability, but they don't have spectroscopic follow-up. But because they're included in works on eruptive YSOs, I put them as candidates. So it's a more limited, I think it's a more limited number of objects here.
Okay, thank you.
Yeah.
Thank you. Very nice work. Thank you. I think I heard in this conference that we expect that variability is more frequent in the early stages. But then I see you have just 5 objects in the embedded phase. So can we do anything about that, or is that a reliable number?
I think the 5 objects that I have are objects that, you know, they were discovered using Spitzer versus WISE, but these were followed up with other, with Sophia as well. So they have seen the variability at those wavelengths. And I say there's only 5 because those 5 they have more follow-up. But I would say that in catalogs like Park et al., VVV, there are more objects that are part of that class. But also objects from VVV, they tend to be bright enough that some of them, not all of them, but bright enough that you can have spectra in the near-infrared. These are objects that there is no way we could get in the near-infrared or optical. So that's why it's more limited. But it doesn't mean that it's less frequent in the class 0, class 1s. And just to finalize that, because I haven't included that, but I think there are many objects that will be included from the JCMT transient survey, because they're looking at sub-millimeter wavelengths. Many of those variable sources, we're still trying to understand what's going on in a few of them, but many of those variable sources are very likely eruptive YSOs, and there's no way we can get that in the optical or near-infrared, only in the sub-millimeter.
Yeah. Carlos, I think what you mentioned, that EX loop has 2 different outbursts and they're classified differently. It's a very relevant problem. So when we did what I presented in my talk for the Gaia things, we made a database, not the objects, but of the accretion events. So I wouldn't be surprised that after some time your catalog would be transferred to a database of accretion events, and maybe one star would have several lines with different characteristics, because they may have different physics. So I think really understanding, you probably have to treat different brightenings of the same source and take them separately.
Yeah, I agree with that. So that's why in this sense, I know that at some point we will reach a different sort of classification scheme based mostly on physical properties. But right now I'm trying to follow the classical definition, which we all, I think, know is becoming very blurred. But that's why I wasn't too sure about trying to start to, I do add some discussion these points in the paper, but I'm not trying to reclassify things right now, because I also think that it might be more useful to present the catalog first, and then maybe a second paper could be on trying to find some new classification system based on physical properties.
There is an online question Okay, I'm going to read. It is from Eleonora Fiorellino. How is that RNO1B is classified as both class 0 and class 2? Is it referred to Quaisten and burst epochs? Also, I think it could be useful to add to the catalog accretion rates when available.
Yeah. As I mentioned, in terms of sort of properties I want to include, accretion rate is one of them. I think once we start talking about luminosity, accretion rate, it does become more limited in the terms of how many objects have this information. But definitely accretion rate is one of the things I want to include. And in terms of that source, the first source in the confirmed table, I think it's because when I was looking at the papers, like it had two different classifications, so it was hard to place it correctly, but it's one of the things that I sort of need to review the table again and make sure. But that's one of the sources that was classified such a long time ago that it's sometimes hard to find the information. But this is a first attempt.
Thank you. We have a question there at the end of the...
Yeah, thank you for your talk and also for the catalog. I just want to ask a short question, and this is whether at some point massive young stellar objects will be included or not. Thank you.
I wanted to include that as well, and I've been talking to Bringfit Steklum. So he was offering to include those as well. But because I wasn't too sure about the exact number of massive YSOs that have been discovered, I know it's not a lot of them, but I wasn't too sure, so I didn't want to include that yet. But I think it would be a good idea to include that in the catalog.
Okay, and the last question.
Yeah, it's related to a question that was asked online about adding the accretion rates. So if you could add a few more derived parameters, stellar masses and so on, radii of stars and so on, I think it'd be useful to attract more theorists, modelers in the field, because if these are available, then that's useful to test the models.
It's something that I wanted to include. But first, because I was trying to gather as much as information, it took a while to get all of this. But as I received more feedback, that's one of the things that people told me. It would be ideal to include more information because it will help people in theoretical models and so on. That's the thing. It does become more. I think some of the classical objects that have been well studied will have more information on those kind of things. There has to be more modeling. But then when we start going to objects like the VVV objects, which are recently discovered, that information becomes more limited. But if we start to include it now, I guess it becomes easier later on as we get more studies, more literature. Then we can start adding those parameters as well.
Okay, and the really last question, the speaker needs to have coffee.
Really short. Well, Carlos, really congratulations. This is undoubtedly a very good legacy project for the future. Are you considering means or methods so that users can submit their candidates to the database?
Yeah, that's one of the things that, because Dirk, I can never say his last name, Dirk Feverick at Kent University, he's the PI of the HOIS survey. I think he has a lot of experience in terms of people sort of being able to give their input and add things to the website. But that's still something that I'm working on, but it would be very useful, especially once we get LSST and all of those new surveys. I think, and that's why I also wanted to do it now, because this is still a manageable number. Once LSST comes, I think it's going to become a bit more difficult, but we can start from here. But yeah, it would be a good idea for people to provide an input.
Okay, let's thanks again all the speakers of this session. And we have the coffee break. We need to come back at 3:30.